Welcome children, good afternoon all of you. My name is P.Sreedevi. I am working in KGBV, Kalasapadu as P.Sreedevi. Today we discuss 9th class Physical Science Motion Part 3. In the previous class we discussed so many topics: speed, velocity, average velocity, etc. topics. Today class we discuss the uniform motion, non-uniform motion, etc. Uniform motion. The motion of the body is said to be uniform when its velocity is constant. Once again, the definition of uniform motion. The motion of the body is said to be uniform when its velocity is constant. Here, instantaneous speed is equals to average speed. Instantaneous speed is equals to average speed. If the direction... Now we observe a figure. A car is moving in various time intervals, various distances. For example, in first 2 seconds, the car traveling 4 meters. In another 2 seconds, the car traveling from 4 meters to 8 meters. Another 2 seconds, the car traveling from 8 meters to 12 meters. And last 2 seconds, the car traveling from 12 meters to 16 meters. Here, the velocity of the car is constant. Here, the velocity of the car is constant. So, for each time interval, the car traveled equal distances. So, it is called. Now, we observe the uniform motion graph. When we take the values of time in x-axis and the distances or displacements in y-axis, when we draw the graph, it is a straight line from horizon. All of you see the figure? In the figure, in all equal time intervals, the distances are same. So, when we draw the graph comes and straight line from horizon. So, when we draw a graph for uniform motion object, it is a straight line from the horizon. So, uniform motion graph is a straight line from the horizon. Okay. Our next topic is non-uniform motion. The motion of the body is said to be non-uniform when its velocity changes continuously. The motion of the body is said to be non-uniform when its velocity changes continuously. So, all of you observe very well here. Velocity changes continuously. Okay. Now see the picture. In that picture, a car is moving in various time intervals in various distances. In first 2 seconds, the car traveling 2 meters. In second 2 seconds, the car traveling from 2 meters to 8 meters. In the third 2 seconds, the car traveling 8 meters to 10 meters. Fourth 2 seconds, the car traveling from 10 meters to 16 meters. So, the car traveling in equal time intervals, various distances. So, this type of motion is called non-uniform motion. So, it is called non-uniform motion. All of you observe the graph of the non-uniform motion. It is a curve from horizon to horizon of the graph. So, in equal time intervals, the distances are various. So, it is a curve graph from horizon. It is not a straight line because always the velocity changes. So, the graph is not a straight line. It is a curve. Okay. So, non-uniform motion distance time graph is always a curve because of velocity is continuously changed here. Velocity is continuously changed here. Okay, now we discuss our another topic. Okay, now we discuss about the lab activity. So now we discuss about the lab activity. Okay, so what is the aim? Aim is to find the acceleration and velocity of an object moving on an inclined plane. So what is the aim? Aim is to find the acceleration and velocity of an object moving on an inclined track. Inclined track means Yetavalu Thalam. Okay. And also to draw the graph between distance and time. To draw the graph between distance and time. Okay. What are the required materials? The required materials are glass marbles, identical books, digital clock, long plastic tubes and steel plate. Once again, glass marbles, identical books, digital clock, long plastic tubes and steel plates. Okay, these are the required materials to do the lab activity. Okay, now we discuss about the procedure. Take a long plastic tube of length nearly 200 centimeters and cut it in half along the length of the tube. So, take a long plastic tube of length nearly 200 centimeters and cut it in half along the length of the tube. Use these tube parts as tracks. Use these tube parts as a track. Mark the readings in centimeter along the track. So, mark the readings in centimeters. Place the one end of the tube on the book. Place one end of the tube on the book and the other end on the floor. So, the other end is put on the floor. Keep a steel plate. Keep a steel plate on the floor at bottom of the track. Keep a steel plate on the floor at bottom of the track. Take a marble having enough size. Take a marble having enough size to travel in the track freely. Marble size is enough. Enough size marble taken. It is travel in the track freely. Okay. Now release the marble freely. Release the marble freely from a certain distance. From a certain distance, say 40 centimeters. So release the marble freely from 40 centimeters. Start the digital clock when the marble is released. When the marble is released, start the digital clocks. It moves down on the track. It moves down on the track and strikes the steel plate. Moves down on the track and strikes the steel plate. Stop the digital clock when the sound is produced. Stop the digital clock when sound is produced near the steel plate. Repeat the same experiment for the same distance 2 to 3 times. Repeat the same experiment for the same distances 2 to 3 times. And note the values of times in the below table. Note the values in the below table. Find the average time and 2s by t square for every trial it gives acceleration. So find the average time and 2s by t square. For every trial it gives acceleration. It gives the acceleration. Draw distance versus time. That means ST graph for the above values in the table. So, draw distance versus time graph for above values in the table. Find the slope. Find the slope. The values found in this experiment are approximately 1. The values found in this experiment is approximately 1. Okay. Is there any relation between the slope and acceleration? Yes. If slope increases, acceleration also increases. Slope increases, acceleration also increases. What do you notice from the distance time graphs for various slopes? If the graph is a straight line from origin, it indicates if the graph is a straight line from the origin, it indicates that the body is in non-uniform motion. If the distance time graph is parallel to time axis, it indicates that the body is at rest. So, if the graph is parallel to time axis, it indicates that the body is at rest. Thus, observing the motion of a ball. Observing the motion of a ball in a inclined plane. Okay. Observing the motion of a ball in an inclined plane. So, here is a inclined plane. Here is a inclined plane. A ball is moving from upwards to downwards. A ball is moving from upwards to downwards. When t is equal to 0, the ball is here. 0 seconds. When t is equal to 1 second, the ball is here. When t is equal to 2 seconds, the ball is here. When t is equal to 3 seconds, the ball is here. Here we observe the motion of the ball. Here we observe the motion of the ball. The direction is same. So top, down, upward to downward. But here the speed is increasing from top to bottom. In first second, the ball moves some distance only. In first second, the ball moves some distance only. In second, the ball moves more than the distance in the first second. In the same way, in the third second, the ball moves more distance than second. So, we can conclude that in an inclined plane, when the ball is moving from top to bottom, the speed of the ball is increasing and also the direction is same. The direction is same. Now we can observe another. Here also an inclined plane, but here the direction of the ball is downward to upward. When t is equal to 0 seconds, the ball is here. When t is equal to 2 seconds, the ball is here. When t is equal to, when t is equal to 1 second, when t is equal to 2 seconds, when t is equal to 3 seconds. Here we observe that at starting, the speed of the ball is more. At final, the speed of the ball is very less. So here we observe that the speed of the ball at starting is very more. At final, the speed of the ball is very less. Here also the direction is set. Here also the direction is set. Here also the direction no change, but speed change. The direction is not no change, but only the speed only change. So from this activity, we can say that in non-uniform motion, direction is same, but the speed changes continuously. This type of motion is also called non-uniform motion. This type of motion is also called non-uniform motion. Next, we discussed another thing, observing the uniform motion, uniform circular motion. Okay. Uniform circular motion. Uniform circular motion. When we take any object, and tied with a string, then we while it, then what is the path of the object? The path of the object is circle. The path of the object is circle. What is the speed of the object? The speed of the object is constant. The speed of the object is constant. What is the direction of the motion? The direction of motion is change towards the tangent of the circle. The direction of the motion is change towards the tangent of the circle. What is meant by tangent? A ray which touches a circle and one point is called a tangent of the circle. So here one object is moved in circular path, uniform circular path. Its speed is constant. But its direction is changes to point. For example, here A, B, C, D, E, just like these are paths. Near point A, the direction of the motion is in this direction. The direction of the object is in this direction. Near point B, the direction of the object, motion of the object is in this way. So we can conclude that the velocity of the object is also continuous changes from point to point. Here speed is constant. But direction is changes. Continuously. So we can conclude that velocity is also changes continuously. So from this activity we can conclude that if we take an object with a thread or string, when we file it, that's speed is constant and velocity is always changes. Okay. Next, we discuss another object. The object which is thrown from the earth with some angle. Object to throw into the air from some angle of the earth. Object throw into air with some angle of horizontal. With some angle of horizontal. Okay. So now we observe an activity. Object thrown into air with some angle of horizontal. Suppose we thrown and stone. We thrown and stone from the air. What is the path of the object? The path of the object is a parabola. The path of the object is a parabola. So here we observe what is the speed and what is the direction. Okay. What is the speed of the object and what is the direction of the object. For example, here we take some points A, B, C, D and also E. Here, F. So, the direction of the object is in this way, from this point to, for example, this is O. From O point to F point. From O point to F point. For example, if we take A point, what is the direction of the object? The direction of the object is straight line. And what is the speed? Here also speed changes. Speed changes, direction changes in each point. At B also the direction of object is this one. At C the direction is this one. At D the direction is this. At E the direction is this. Okay, in each point the direction is changes. In the same way, the speed also changes continuously. So, speed changes, direction changes. So, both are changes. Both are changes. Okay. So, we conclude that speed change, direction change means velocity also changes. Velocity also changes. So this is the one of the example of non-uniform motion. Now we discuss what is acceleration. Acceleration. What is acceleration? If an object is moving, then the speed changes or direction changes or both changes. Then the velocity is also changes. So when the velocity changes, that body is called accelerated body. So speed change. Speed change. Direction change. Direction change. And both velocity change. Which body's velocity is changes continuously, that body is called accelerated body. Once again, what is acceleration? If an object's speed change or direction change or both change, that's velocity is changes. Which object's velocity is changes continuously, that body is called an accelerated body. So, when we feel acceleration, when in our daily life we feel many situations. In our daily life, many situations. For example, if we are traveling in a bus, we are sitting in a seat. When the driver is press the accelerator, we feel the acceleration. Opposite of the seat. Opposite of the seat. Okay. When we travel a bus, and the driver press accelerator, our body towards the seat. Thrown towards the seat. Okay. For example, a car is moving in 1 second 30 kilometers per hour. Another second 30 kilometers to 35 kilometers per hour. Another second that moves 35 kilometers per hour to 40 kilometers per hour. Okay, so in first second the car travel 30 kilometers to 35 kilometers. In another second the car travel 35 kilometers to 40 kilometers per hour. What is the difference? Here is difference 5 kilometers per hour. Here also 5 kilometers per hour. So, what is the acceleration of the car? What is the acceleration of the car? The acceleration of this car is 5 kilometers per hour. 5 kilometers per hour. So, finally, we discuss what is acceleration. Acceleration means the rate of change of velocity. The rate of change of velocity. The rate of change of velocity is called acceleration. Acceleration. Okay. So, acceleration is denoted with letter small a. Acceleration is denoted with the letter small a. Small a is equals to delta v by t. Here delta means difference of velocity. Difference of velocity. So acceleration is equals to delta v by t. What is the SI unit? SI unit is equals to, all of you know very well, what is the unit of velocity? Velocity unit is equals to meter per second. Time unit is equals to second. Okay. What is the unit of SI unit of A? A is equals to meter per second square. Meter per second square. Okay. Here acceleration is means always increasing velocity is not. Always increasing velocity is not. Sometimes the acceleration is also decreasing. Sometimes the acceleration also decreases. That is called deceleration. That is called deceleration. The negative value of acceleration is called deceleration. But what is the examples of acceleration and deceleration. When a train is moving from one station to another station, then the velocity is increasing. When train is moving from first station to second station, then the velocity is increasing. Then the velocity change is called acceleration. When that train reaches the second station, then the velocity is decreases because of to stop the train. In second station, then the velocity is decreased. In that case, the velocity is decreases. That type of acceleration is called deceleration. Now we discuss equations of uniform accelerated motion. Equations of uniform accelerated motion. Okay. Then an object is traveling in a straight line. An object is traveling in a straight line. At t is equal to 0 seconds, the object is here. When t is equal to t seconds, the object is here. The displacement of the object in t seconds is equal to s meters. So, an object is moving in a straight line. When t is equal to 0, the object is here. When t is equal to t seconds, the object is here. The displacement travelled by the object is equal to s. The displacement travelled by the object is equal to s. Okay, here acceleration A is constant. Acceleration A is constant. We know that acceleration is equals to change in velocity by time. Change in velocity by time. Here A is equals to delta V by delta T is equal to constant. Delta V by delta T is equal to constant. Acceleration A is equals to change in velocity by time. Acceleration is denoted with small a. Change in velocity means delta V. Here delta means change by time. Delta T. Let U is the displacement. Let U is the velocity in time t is equal to 0 seconds. Time t is equal to 0 seconds. V is the velocity in time t is equals to t seconds. S is the displacement. S is the displacement travelled by the object. In t seconds. Object travelled is s meters, displacement in t seconds. Okay. We know that acceleration A is equals to delta V by delta T. Okay. That means delta V means, we know that here this is initial velocity, this is final velocity. Delta V means V minus U by T. So A is equals to AT. Call this equation number 1. Okay. Once again, an object is moving in a straight path. When the time is 0 seconds, the object is here. When the time is 3 seconds, the object is here. In 3 seconds, the object moved s meters. So this is the displacement of the object. We know that here uniform accelerated motion means a is constant. Acceleration is equals to change in velocity by time. Small a is equals to delta v by delta t. That is equals to constant. U is the velocity in time t is equal to 0. V is the velocity in time t is equal to t seconds. So s is the displacement traveled by the object in t seconds. So acceleration a is equals to delta v by delta t. Here delta v means change in velocity. So final velocity minus initial velocity by time. So a is equals to v minus u by t. That is implies a into t is equal to v minus u. When we taken this minus u to this side, then v is equals to u plus at. This is equation 1. Okay. Since a is constant, average velocity is equals to average velocity is equal to v plus u by 2. Average velocity is equals to v plus u by 2. We know that average velocity is equals to displacement by time. That is equals to s by t. So this is average velocity and this is also average velocity. So here average velocity is equal to v plus u by 2. Here average velocity is equal to s by t. So when we equal these two, v plus u by 2 is equal to s by t. v plus u by 2 is equals to s by t. Call this equation number 2. Call this equation number 2. From equation 1 and 2, we substitute v value in equation 2. We substitute v is equal to u plus at in equation number 2. Okay, then what is the value of v here in equation 1? That is equals to u plus at. This is the v value. Again, here is plus u by 2 is equal to s by t. So here we substitute the v value. That means equation number 1. v is equal to u plus at in equation 2. So this is the v value and remaining is same. So when we add u plus u is equals to 2u plus at by 2. That is equals to s by t. Next, we do the cross multiplication. T here to here. So 2u plus at into t is equal to 2x. Two u into t. 2u plus half at square. This is equation number 3. S is equal to ut plus half at square. This is equation number 3. Okay. From equation V is equal to U plus AT. From equation V is equal to U plus AT, T is equals to V minus U by E. From equation V is equal to U plus AT, T is equals to V minus U by E. We substitute the T value in equation number 2. Substitute T value in equation 2. What is equation 2? V plus U by 2 is equals to S by T. So here in the place of T, we substitute T is equals to V minus U by A. So V plus U by 2 is equals to S by, what is the value of T? T is equals to V minus U by A. Okay. So when we do this one to this side, V plus U by 2 is equal into V minus U by A is equals to S. Okay. All of you know very well in mathematics what is the formula of A plus B into A minus B is equals to A square minus B square. All of you know very well this formula. A plus B into A minus B is equals to A square minus B square. Here B plus U into B minus U. We take this 2 and A for other side. So then it becomes 2AS. So A plus B into A minus B is equal to A square minus B square. Here B plus U into B minus U is equals to B square minus U square is equals to 2AS. This is called equation number 4. Now we discuss a problem. What is the average speed of a cheetah that sprints 100 meters in 4 seconds? What if it sprints 50 meters in 2 seconds? So, average speed. To find the average speed when the cheetah sprints 100 meters in 4 seconds and 50 meters in 2 seconds. Okay. First, given distance is equals to 100 meters. Given distance is equals to 100 meters. Time is equal to 4 seconds. Time is equal to 4 seconds. So, what we find? We find average speed. Average speed. We know that average speed is equals to total distance by total time. We know that average speed is equals to total distance by total time. Here total distance in first case is equals to 100 meters. Time taken is equals to 4 seconds. So, total distance by time taken is equals to 100 by 4. 100 by 4. That is equals to 25 meter per second. So, the average speed of cheetah that sprints 100 meters in 4 seconds is equals to 25 meter per second. In the second case, the given distance is equals to 50 meters. Time is equals to 2 seconds. So we find average speed. Average speed is equal to, what is the formula? Total distance by total time. So total distance, how much here? Here total distance is equals to 50 meters. Time is equals to 2 seconds. So the average speed is equals to 25 meter per second. Average speed in the second case is 25 meter per second. So in the first case, average speed is equals to 25 meter per second. In the second case also, the average speed is equals to 25 meter per second. So by observing that in both cases, the average speed, in both cases, the average speed of cheetah is same. So when the cheetah travel 100 meter in 4 seconds, and also when the cheetah travel 50 meters in 2 seconds, totally the average speed is equals to 25 meter per second. Okay. Now we discuss another problem. An object moving with 6 meter per second. An object moving with 6 meter per second. Execute an acceleration 2 meter per second square in next 3 seconds. So what is the acceleration? 2 meter per second square in next 3 seconds. How much distance it covered? How much distance it covered? Which one here we taken here? S is equals to ut plus half at square. So here we find the S. Here we find the S. In the given U means initial velocity. U means initial velocity. What is the value of initial velocity? Here 6 meter per second. 6 meter per second is the initial velocity. Next, what is the acceleration? What is the acceleration? Acceleration A is equals to 2 meter per second square. Acceleration A is equals to 2 meter per second square. How much time taken? The time taken is equals to 3 seconds. The time taken is equals to 3 seconds. So now we take the formula. S is equals to ut plus half at square. What is the formula? S is equals to ut plus half at square. We substitute the values of u, t and a in the given formula. Then 6 into 3 plus half into 2 into 3 square. We know that 6 3s are 18. Here 2 is cancelled. So 3 square means 9. What is the sum of 18 plus 9? 18 plus 9 is equals to 27 meters. So moving object covered distance. How much? Moving object covered the distance 27 meters. So the covered distance is 27 meters. Okay. Now we discuss another topic, another problem. A car stopped after traveling distance 8 meters to applying brakes at the speed of 40 meters per second. A car stopped after traveling distance 8 meters due to applying brakes at the speed of 40 meters per second. Find acceleration and retardation of car in that period. What we find here? Acceleration and retardation. Acceleration and retardation we find. So, which values are given here? The initial velocity. The initial velocity is given. What is the value of initial velocity? Initial velocity u is equals to 40 meter per second. Initial velocity u is equals to 40 meter per second. Next, what values given? Distance. Distance traveled how much? Distance traveled 8 meters. So, S is equals to 8 meters. S is equals to 8 meters. Final velocity V. Final velocity V. Here the car stops. That means final velocity is how much? The final velocity V is equals to 0 meter per second. Final velocity V is equals to 0 meter per second. We find acceleration and retardation. We find acceleration and retardation. So, acceleration A we find. What is the formula we use here? Given values are V, U and S. So, we find A. What is the formula related these terms? The formula related these terms is equals to V square minus U square is equals to 2AS. V square minus U square is equal to 2AS. So here V is equals to how much? 0. U is equals to 40 and S is equals to how much? S is equals to 8 meters. So we substitute the values of V, U and S. In V square minus U square is equal to 2AS. Then 0 square minus 40 square is equals to 2 into A into 8. But we find A. So A is equals to minus 1600 by 16. How much? Minus 1600 by 16. So, when we calculate minus 1600 by 16, what comes? Here minus symbol comes the same. So, 16 ones, 16 hundreds. So, that is equals to minus 100 meter per second square. So, acceleration is equals to minus 100 meter per second square. So, acceleration A is equals to minus 100 meters per second square. What is retardation? The negative symbol of acceleration is called retardation. Here acceleration means minus 100 meter per second square. So retardation is equals to minus of acceleration, that is equals to minus of minus 100 meter per second square. So minus of minus, so minus into minus becomes to plus. So that is equals to plus 100 meter per second square. So finally acceleration is equals to minus 100 meter per second square. Deceleration or retardation is equals to 100 meter per second square. So these are the values. Okay. So we know that acceleration and retardation are opposite sign. Have acceleration and retardation have opposite signs. Okay.